Welcome back, Math 45 students. This is Cindy Enrique, and we are going to continue with Chapter 3. We're going to start on page 18. So here we go. We're going to continue with our remote online learning. So Section 3.5, Transformation of Functions. So this section kind of starts off with all of these shifts and transformations and moving it to the left or to the right, up or down. So this is going to be a very important section. So a vertical shift, that means going up or down. So remember, vertical means up or down. So given a function, if I have f of x plus k, where k is a constant, then what we're doing is we're moving it up by k units. If it's negative, then you're moving it down by k units. So what this is saying is if I have f of x plus k, what this is saying, we're going to go up k units. Versus if I have f of x minus k, that subtraction means that we're going to be going down k units. Okay, so plus is for up and minus is for down. And remember, it's at the end. So the entire function plus something or the entire function minus something. That's going to be very important. So, for example, look at the graph to the right. So here we see our original graph. Our original graph is f of x. Okay. Now, the orange graph is actually the graph plus 1. So everything got moved up 1 unit. Okay, so that's my function getting moved. So it's the exact same shape, the exact same points, except just moved up by 1. For example, you can see that this 0, 0 point is up here. It got shifted up by 1. This point at 1, 1 got shifted up. So now it's 1, 2. So what's happening here is all the y values got moved up 1. So this y value at -1 got bumped up. So everything got bumped up by a value of 1. Okay, so that is our vertical shift plus 1. So let's put this into play. So we have the graph of f of x, it's provided below, and we want to make sure that we graph our new function. So our new function is going to be called g of x. And g of x is the same as f of x, except it's going to be shifted down 3 units. So shift original graph down by 3 units. So that is what it's saying here. So I'm like, okay, well, let's look at some key points here. This point right there, we have that as 3, 1. Okay. Maybe another point to realize is here. That point here is 6, 7. And this point right in there in that parabola is going to be 0, 7. So maybe I'm going to go ahead and write that other point right below it so that way I know what I'm writing. So remember, this is 3, 1. That makes it a little bit better. So if I want, I can go ahead and make my points of f of x. I don't know exactly what the function is, although just by looking at it, I can see that it's going to be a parabola. But I know that my points are 0, 7, 3, 1, and 6, 7. So my new function g of x, what's going on there is I'm still going to have the same x values. So I still have 0, I still have 3, and I still have x. So same x values. Now for all of my y values, what's going down is I'm going to subtract 3. So subtract 3 from the y values. Okay, so let's think about that. If this is my value that I'm thinking about right here for my g of x, that means I'm going to go down 3 units. So 1, 2, 3. So now that is going to be it's going to be 3 comma negative 2. And you can see that here, because I have that y value of 1, and I'm minusing 3, and that gives me a negative 2. That's how I got that negative 2 over here. Likewise, if I have my 7 up here, I'm going to go down 3. So 1, 2, 3. So now that new point is going to be 0, comma 4. So now I have 0, 4. And yes, I can think about that as 7 minus 3 is equal to a positive 4. So you can either calculate it by hand or do it visually. This point over here, I'm going to go ahead and subtract 3 from the y value. So 1, 2, 3. So now that new value is going to be 6, comma 4. And again, if you want to do algebraically, 7 minus 3 gives me a positive 4. So now I have my new points. And I know that it has the shape of a parabola. So that is how I'm going to be graphing my g of x, which was f of x minus 3. Every point got shifted down by 3. Okay? All right, well, I hope that makes sense. So now, for the next example, we're going to have a horizontal shift. So the horizontal shift means we're going to be going to the left or to the right. And this is actually kind of counterintuitive. Students are always just like, why is it like this? It just is. So we have f. Now inside the parentheses, inside the function, if I have x plus h, okay, what that tells us is we are going to the left h units. And for our second one, if I have f of x minus h, well, then that means we are going to the right by h units. So we have to be very careful with that. So we're going to the left and we're going to the right. So as we can see from this example, we have our original again. So here's my f of x. And now we have an f of x plus 1. So since it's plus 1, that means I'm going to the left 1 unit. So I can see that this point over here, 0, 0, got shifted to the left. That's my new point. This point over here got shifted to the left. That's my new point. Okay? And this point as well, it got shifted, so it's over to the left. So hopefully that makes a little bit of sense. So for our next example, we actually have this. We have f of x shown, and we want to graph g of x. So it's like, okay, we want to graph g of x such that g of x is f of x minus 2. This is important to notice that that minus is inside the parentheses. So when it's inside the parentheses, I know I'm moving everything to the right 2 units. So right 2 units. Okay. So I'm going to do this visually. Make the graph a little bit bigger for you. So, okay, here we go. So here's my point that I can recognize, and I know I'm going to the right 2 units. So 1, 2. Now I'm over here. So that helps me out. And let's say I want to use this point over here. So that means I'm going to be moving to the right 2 units. So 1, 2. Now that's my point. And let's say I'm going to use this point over here. So I'm going to be going over to the right 2 units. So now I'm going to have my graph with these 3 points. So that green graph shows that everything got moved over by 2 units. That is going to be my new g of x, which was f of x minus 2. Okay, well, let's continue on in this path. Now, we are going to have to graph my original function. My original function was f of x is equal to the absolute value. So hopefully you know when f of x is equal to the absolute value of x, we're going to have some points. So we have some x and some y points. So I know the absolute value of 0 is 0. The absolute value is 4 is 4. The absolute value of negative 4 is also a positive 4. And I think that's enough. So let's see how that goes. So I have 0, 0. I have 4, 4, and negative 4, 4. So my original graph more or less looks like this. So this is my f of x. Now what I want to do is I'm going to graph my g of x. So I know that g of x is going to equal to x plus 1 minus 3. So now my graph is going to look slightly different. That plus 1 tells me I'm going to be going to the left 1 unit. And also tells me I'm going to be going down 3 units. So that plus on the inside tells me to go left. That minus on the outside tells me to go down. And you can also get your points by graphing this on your calculator. So if you go to you can go on your calculator to help you with points if you really need to. So if you go to your y equals, you're going to input your equation. So that equation, sorry there guys, I keep getting this. So I'm going to have my absolute value. So I'm going to go to my math. And I'm going to have to go to my adds. That's where my absolute value is. Now I'm going to enter in my x plus 1. And I'm going to have a subtract 3. And if I go to my second and then graph, what that shows me is going to be an actual table. So I can actually get some points there. So if I'm looking for some points, I have 0 and I have a negative 2. I'm also going to have 4 and a positive 2. And I'm going to have a negative 4 and a 0. And if you're like, whoa, I didn't understand that. That's okay. 1, I did it on my calculator. But 2, I know exactly what I'm supposed to do. So from this point right here, 0, 0, it says go down 3. So 1, 2, 3. And I'm going to go to the left 1 unit. So that is here. And this point is 0. Oops. Let's see. So I am going to be I messed that up. Let's try that again. Okay. So we were at 0, 0 right here. And it says go down 3, 1, 2, 3. Now I'm going to go to the left 1 unit. So now I'm at negative 1, negative 3. And that's okay. Negative 1, negative 3. And negative 1, negative 3 is actually on my graph. Okay? Now over here for this point, I'm going to go down 3, 1, 2, 3, and to the left 1. So then that point is going to be negative 5, positive 1. And this point over here, same thing, going down 3, 1, 2, 3, and to the left 1. Okay? Or I could have just graphed some of these points. So I have 0, negative 2, which is fine. I have 4, positive 2. and I have negative 4, 0. So these points I got from the calculator. And then these points I actually got from moving these around. So this point corresponds to this point, and this point corresponds to this point over here. Okay. Hopefully that makes sense. And don't worry, we're going to have plenty of more examples to go over this. So just know I went down 3 and to the left 1 visually, and I also did it on my calculator by putting in some points. All right, now we're going to have some reflections. So the reflections are going to be a vertical and horizontal reflections. So you can see that my original graph, which is this one, can get reflected in certain ways. So if I have a vertical reflection, that's here. If I have a horizontal reflection, that's here. This is my horizontal reflection, and this is my vertical reflection. And if you're like, wait a minute, what is going on here? Well, it gets reflected across the x or the y axis. So if I have a negative f of x, so the negative is in front of the entire function, then it is going to be reflected across the x-axis. So here is my vertical reflection. Now for the second one, I actually am going to have f of negative x inside. So this tells me I'm going to be reflected across the y-axis. And this is, of course, talking about my horizontal. So you can see the vertical reflection is along the x over here, okay? Versus my horizontal reflection, that gets kind of switched over along the y. So let's see how that's going to look. So for this one, it says, hey, reflect the graph of s of t. So it's a square root, and we want to reflect it vertically. So vertically is going to be your key word here. So that key word, vertically, that's going to tell you it's a negative f of x. So I know that I'm reflecting across the x-axis. And so that tells us that the y values change signs. Okay. Since it's reflected across the x-axis. So let's think of some key points here. So this point right here, I have 0, 0. I also have this point right here, which is 1, 1. And I also have the point over here, 4, 2. So if I'm going to be reflecting this across the x-axis, that means my y values are going to have the opposite sign. So 0, 0. So let's write this over here. I'm going to have 0, 0. And when it gets reflected, well, 0, 0 is going to remain the same because 0 is not positive and it's not negative. So it's still there, 0, 0. I also have my 1, 1. So when that gets reflected across the x-axis, my y value is going to change to a negative 1. So now I have 1, negative 1. Okay? So that is my 1, negative 1. Now for my next one, I have my 4, comma 2. Remember, I am changing my values of y to the opposite sign. So now the x does not change, but now I have a negative 2. So I'm going to have 4, negative 2. So now my graph is going to look like this. So there's my arrow. Doesn't have to be so perfect, but you guys get the gist, okay? It's going to have that curve, so it got reflected. So you can see it's the mirror image across this x-axis. So that curve now gets, you can think about it as you folded a paper over and now it's down at the bottom. Okay. Now for this next one. So that was vertically. For the next one, it's almost the exact same thing, except it's slightly different. Now it says horizontally. So it's the exact same equation, except it's specifically saying horizontally. So this is saying that f of negative x, so it's reflected across the y-axis now. Okay. So you're going to change your x values. And you're just like, okay, I think I'm getting the gist of this. So I still have my original points. I still have my 0, 0. I still have my 1, 1. And I still have my 4, 2. So let's see how all of those points are going to be changing. So again, I had 0, 0. I had 1, comma 1. And I had 4, comma 2. So when I'm changing this as a reflection across the y-axis, the x values are changing. So my x value, x value, x value. So negative 0 is still just 0. 0 is neither positive nor negative. But now I have a negative 1, positive 1, and a negative 4, positive 2. So I have 0, 0, negative 1, 1, and negative 4, 2. So now my graph, reflected across the y-axis, looks like that. Okay. Hopefully that helps. Now, for the next example, we have several things going on here. We have our original function, which is exponential, and that's here. So this is my original. Okay. Now what I want to do is I want to graph these different things that's going on. And you're just like, okay, well, what I want to do first is go ahead and deal with my vertical reflection. So I'm going to deal with this negative 2. That negative 2 deals with the vertical reflection. So you can think of this as my function, let's call it g of t, is equal to a negative 2 to the negative t function. Okay. And what might be the easiest thing to do here is to actually just graph this to get points on your calculator. Okay. So on calculator, get points. Okay. That's going to be the easiest thing. And when you get your points, you're going to get a 0, negative 1, You're also going to get a -2, -3. And you're also going to have kind of like this asymptote, since this is an asymptote, okay? And your other point is going to come very, very close over here. So this is what your graph is looking like, okay? Now, because I have that +1, this +1, the function that I'm graphing is now my k of t, which is at -2, -t plus 1. So I'm really considering now that +1. So that means I'm going to be moving all of my points up 1. So this asymptote, because it was at 0, 0, it gets shifted up. So now it's at +1. That's my asymptote. So now my new graph, well, if I was at 0, -1, I'm going to go up and I'm going to be at 0, 0 now. This point over here, if I was at -2, -3, now I'm going to shift it up and be at -2, -2. So now I know more or less that my graph is going to look like that. That is my end graph. And really, your calculator is going to be your best friend in this section. Now, we're going to talk about vertical stretches and compressions. So the biggest thing I want to talk about is when you have y is equal to a times f of x, what that's telling you is to multiply your y values by a. Okay? That's what you're doing. So, for example, I have this, so I am moving everything as a vertical stretch. So given the graph of P of t, graph Q of t, where Q of t is equal to 2 times P of t. And you're just like, okay, well, I think I understand what's going on. So I'm going to write down my original problem here. So here's my original graph. Now I'm going to get some key points from that original graph. So this original point over here, so original, and that original graph was P of t. I'm going to find my x and some y values. So over here I have 0, 1. So I'm going to go ahead and write that down, 0, 1. This point in here is a 3, 3. So I'm going to go ahead and write 3, 3. And this point right here is a 6, 2. So we'll have 6 and 2. And my other good point is right here, which is a 7, 0. So 7, 0. So those are all of my original points. Now what I want to do, I want to think about my Q of t. My Q of t, remember, it's 2 times P of t. So what that tells me is, hey, multiply y values by 2. So all of my x values are going to stay the same. So I still have 0, I still have 3, I still have 6, and I still have 7. But now I'm going to be multiplying these y values by 2. And I multiply them by 2. I'm going to go ahead and write them over to the other side. And now I have the points that I'm going to be graphing. So I'm just going to clean up my graph, so then that way I can have space. So now I'm going to see exactly where these new points are. So now I have 0, 2. I have 3, 6. I have 6, 4. And I have 7, 0. So now I can see that this graph got stretched by 2. So it's the same graph, except it's just stretched. I hope that makes sense. We are going to be moving on to our next example. So for this one, we're going to be talking now about our horizontal stretches and compressions. So here, when I have that y is equal to f of b times my x value, then what we're doing is we're going to multiply all of our x values by 1 over b. So, okay, so that's what's happening. So whenever I multiply by a fraction, what ends up happening is you actually are kind of either stretching it and compressing it. So let's put this into play. So it's the same graph as before. Well, almost. So we still have our P of t, and here's my original graph of P of t. So again, I'm going to go ahead and write down these points. So I'm going to have here 0, 1. I have this point as 3, 3. And I still have my 6, 2. And I still have my 7, 0. So my P of t, which is my original, I'm going to have my points x and y as 0, 1, 3, 3, 6, 2, and 7, 0. Now, what I'm going to be doing for my q of t is, you remember, I'm going to be multiplying all of my x values by 1/2. But my y values are still going to be the same. So this is telling me multiply x values by 1/2. So my y values stay the same. So I have 1, 3, 2, and 0. So I'm going to multiply this by 1/2. Well, 0 times anything is just 0. This times 1/2 gives me a 3/2, which is the same as saying 1.5. So maybe you can say it's the same as 1.5. And sorry, there's a negative sign in there. Shouldn't be negative. I was trying to say an equal sign. So equals. If I multiply 6 by 1/2, well, 1/2 of 6 is going to give me 3. And if I'm going to multiply this one by 1/2, then that's going to give me 7/2. And again, it might be easier to go ahead and write this as a decimal. So 7/2 is the same as 3.5. And that's an equals, not a negative. Okay. So, all right, I'm going to kind of clean up my original graph, so that way it's a little bit more clear on what I'm doing over here. So here are going to be my new points. So I have 0, 1. That did not change. So I'm sharing a point. Now I have that 1.5. So 1.5 is smack between 1 and 2. So I'm somewhere in there. So okay, that's fine, but I need to go up to positive 3. So I'm like right here. Now I also have 3, 2. So I'm over here. And I have 7/2. So that 7/2 is really 3.5. So 3.5 is in the middle of 3 and 4. And I am going to have that as 0. So here is my 0. So now my graph is here. So I had my 0, 1, my 3/2, 3. I have my 3, 2, and my 7/2, 0. Okay. So that is how I graphed it. I graphed my q of t by multiplying all of my x values by 1/2 and keeping all of my y values exactly the same. Okay. So hopefully you guys are getting it. If not, you guys can always email me. We can do a Zoom conference, or we can Google some images together. Or Newton on your homework actually has some good examples. So here we're going to be combining transformations. So we have my original function. We don't know exactly what it is, but it's telling us to transform them in such a way. So, okay, so the first thing I want to do is I want to get some essential points here. So this point, I'm going to have these as my original points, and we're going to see how each one gets transformed. So that's a -2, 0. This point right there is a 0, 2. And the last point of interest over here is 2, 0. So now I'm going to be working with 3 points. Now I'm going to see how each one is going to be transformed. So the first translation that I'm going to do, since there's a lot going on over here, I'm going to do f of 1/2 x. Okay. So because that is happening, that means I'm only going to be working with this point in there first. So I'm going to have my new x and y values. So my y values stay the same. I have a 0, I have 2, and I have 0. And it's telling me that all of my x values get multiplied by 2. So x values multiply by 2. So times this by 2, times that by 2, times that by 2. So now I'm going to have my new x and y values. So my new x and y values, oops, I already had them. So my new x and y values, I'm going to have this as a -4. 0 times anything is still 0, and 2 times 2 is 4. So, okay, now I have -4, 0, 0, 2, and 4, 0. So now I can see that my graph kind of got stretched out. Now it's a little bit fatter than I thought it was going to be. And that's fine. We're just doing this very slowly. So now we're going to think about our next action. So our next action, what might be helpful is to go ahead and shift this to the left by 2 units. So actually, it's going to be shifted to the left by 1 unit, okay? So this +1 tells me to go to the left 1 unit. Okay, so I'm going to have my new x and y values. So if I'm going to be moving everything to the left 1 unit, well, that means that my y values still stay the same. So I still have 0, 2, and 0. So I am going to, on my x values over here, I'm going to shift them over by 1. So now that becomes a -5. And I shift it over by 1, now I have a -1. And I shift this over by 1, now I have a -3. So now I have my new points. So this is all going to become, maybe if I make it smaller, there we go. So now I have -5, 0, -1, 2, and that should have been a +3, shouldn't have, there we go. +3, 0. So now I can see that everything got shifted to the left. So left 1 unit. Okay. Now, for the next one, what's happening next is I have this -3. That -3 tells me to go down 3 units. So, okay. So now I'm going to have my new values. So that means my x values aren't going to be moved. So I'm going to go down 3 units. So 1, 2, 3, 1, 2, 3, and 1, 2, 3. So that new point, I still have a -5, -3. I have a -1, -1, and I have a +3, -3. So -5, -3 is here. -1, -1 is there. And 3, -3 is here. So now that is going to be my new graph. So you can kind of see how all of these problems get kind of messed with. And this was the down 3 units. So this last graph here is the final graph, which is the f of 1/2 x plus 1 minus 3, meaning that I ended up doing a bunch of stuff to the graph. Okay, I hope that makes sense. Now we're going to have our even and odd functions. So if we have an even function, then that's going to be this definition. So if we have something that's even, what it's describing is going to be describing the y-axis. And if I have something that's going to be odd, then we are thinking about the origin. Okay. So my even function, it says an even function. The graph of an even function is symmetric about the y-axis, versus the odd function is going to be symmetric about the origin. So hopefully you understand what symmetric means. It means that if you have something cut in half, then each side should look the same. So let's look at these graphs below. So when I'm looking at these graphs, I see this parabola. Well, where is the mirror image? Well, I can see that the origin is here. So if I'm thinking about the origin, is this side the same as this side? No, so it's not symmetric about the origin. So that doesn't help us at all. Now, is this going to be symmetric along the y-axis? So that's the y-axis over here. Is this side the same as this side? is it the mirror image? Well, yeah, it does look like it's going to be the mirror image. So we can say that this is going to be even. It is the mirror image along y. So just remember, it's the mirror image along the y-axis. Okay. So this side looks exactly like this side. So quadrant 1 looks the same as quadrant 2. Those look exactly the same, the mirror image of each other. So now, let's think about this graph in the middle. So would it be symmetric about the origin? Well, if it's symmetric about the origin, does it mean that this side is the same as this side? No, it doesn't look like that. So it cannot be symmetric about the origin. So now let's think about the y-axis. So here's my y-axis. Is this side the same as this side? No, it isn't. So it's not symmetric along the y-axis, and it's not symmetric about the origin. So I'm going to say it's neither. Okay. Now let's think about the y-axis here. Let's see if it's even. If it's even, is this side the same as this side? No, because here I have my purple graph. So I would need to have another purple graph over here, and I don't. So it's definitely not going to be symmetric along the y-axis, so it's not going to be even. But now let's see if it's symmetric about the origin. So if it's going to be symmetric about the origin, here and here, well, is this side the mirror image of this side? I think so. This is going up and this is going down. And if you think about it, you can like fold over quadrant 1 to look the same as quadrant 3. And because that is so, I can definitely say that these are symmetric. Okay? So quadrant 1 and quadrant 3 are symmetric. So because that's so, I'm going to say that this is symmetric along the origin. So it tells me it's going to be odd, since it was the mirror image along the diagonal. So that is how to represent even, odd, or neither symmetry according to the graph. Now, let's do it algebraically. So you will want to know whether something is even, odd, or neither. So we're going to have to determine. Well, let's see what happens when we plug in a negative x. So here's my g function. So I have my g. And now what I'm going to plug in is going to be a negative x. Let's see what happens when I plug that in. So here's x to the 4th power minus 2 x squared minus 5. So what I'm plugging in is a negative x. Let's see what happens. So here, 4 and a negative. So negative times a negative times a negative times a negative. That's a negative 4 times. So that's going to be positive. So I have a positive x to the 4th. Here I have a square. So negative times a negative is a positive. So I still have a negative 2, and now that's a positive x squared. And now I still have a negative 5. So let's compare that to my original equation. So it's exactly the same as my original equation. Here's my original, and it looks exactly the same. So exact same as my original equation. So I can see that g of negative x is the same of g of x. So if I'm looking at my definition, I can see that f of x is equal to f of negative x. That's this first one over here. So whenever I plug in a negative x, I get back my original function. So since that's the case, I know that this is going to be even, since I'm looking at that definition. Okay, so now let's see what happens with our next one. So for part B, let's see, I have f. Now I'm going to plug in now a negative x, and let's see what happens. So I'm going to have parentheses to the third plus 2 times parentheses, because what I'm plugging into the parentheses is a negative x. So I have negative x to the third power. Well, negative times a negative times a negative is negative, so this is still negative x3. And this is going to be a negative times a positive, so it's a negative 2x. So if I'm comparing my original function to this new function that I have over here, I can see that I actually have the exact opposite sign. So exact opposite as my original equation. So I end up getting that f of negative x is equal to a negative f of x, meaning all of my signs of my original functions changed. So if I was looking at that definition is here. The f of x is equal to the negative f of negative x. So now I can say with certainty that this function was odd. Okay. So it all depends on what you plug in and what you get out. So you're always plugging in negative x to determine even and odd function. What you get out is going to determine whether it's even or odd. Okay, well I hope this makes sense, and if not, you know how to reach me.